Hi, I'm Eros Fani, and I'm going to present our work, Accelerating Heterogeneous Federated Learning with Closed-Form Classifiers. This is a joint work with Raffaello Camorriano, Barbara Caputo and Marco Ciccone at the Polytechnic University of Turin. Federated learning is a decentralized machine learning framework that enables collaborative training across devices located at different places. Clients perform local training to protect privacy, and data never leaves their devices. Active clients directly communicate their local models to a central server, which aggregates them to create a new initialization for the next round of training. In real-world scenarios, only a few clients contribute to the training during each round. Clients' data reveal individual user habits, preferences, and locations, which challenges the traditional assumption in machine learning that all data points are independent and identically distributed. This is known in federated learning as statistical heterogeneity. During training, statistical heterogeneity causes local updates to diverge from global optimum. Consequently, the overall speed of convergence can be significantly reduced. Recent works show that, in neural networks, client drift primarily affects the classifier. In this example, the clients have access to different classes. Suppose client K is the only one with access to the class dog. Because of partial participation, the same client is typically not sampled in two consecutive rounds. If client K is sampled in one round but not in the next round, the model can develop data recency bias. This phenomenon is well studied in areas such as continual learning. In classification, this phenomenon occurs due to the inherent nature of the softmax classifier, which is prone to forgetting if updated by sampling data in a non-IID or class imbalanced manner. Therefore, in this work, we aim to answer the following question. Is it possible to design an efficient FL method that is robust to client drift in heterogeneous settings and unaffected by the classifier bias? Luckily, the answer is yes, exploiting the properties of closed-form linear classifiers. Indeed, we propose a new robust and efficient algorithm for federated learning based on ridge regression, which we named Federated Recursive Ridge Regression, in short FET3R. Thanks to the linearity of its formulation, FET3R is immune to statistical heterogeneity, guarantees faster convergence than the baselines, and severely reduces computations and communication costs. In addition, we propose two additional variants of FET3R. FET3R-RF, a nonlinear version of the algorithm based on random Fourier feature mappings to approximate the kernel ridge regression solution while keeping the same properties of FET3R, and FET3R plus FT, which allows fine-tuning the whole model, the feature extractor only or the classifier only after initializing the model with the FET3R classifier. Ridge regression admits a closed-form solution for a linear classifier, and previous works show that it can also be used for the classification task. We exploit a pre-trained feature extractor phi to map the input to the latent feature space. Then, we repurpose ridge regression for federated learning to stack a linear classifier on top. During the first step, each client computes its local statistics using its own local data, as shown in the picture. Later, the server collects these statistics and aggregates them to form the matrices A and B, which are used to compute the optimal regularized least squares classifier. The aggregation guarantees an exact solution equivalent to the centralized solution. Both FET3R and FET3R-RF are immune to statistical heterogeneity, as their performance is the same as that of the centralized solution. This is shown in the plot on the right. Once all clients have participated in the training, both algorithms consistently converge to the same value, regardless of the number of clients and the distribution changes in the dataset across the clients. In our work, we always focused on real-world cross-device experiments with thousands of clients and high statistical heterogeneity, where classical gradient-based algorithms struggle. Moreover, FET3R is guaranteed to converge in a single pass on clients, inherits the generalization properties of ridge regression, and is memory and computation efficient. Similarly, here we compare the FET3R plus FT variants with the baselines on the iNaturalist dataset. In federated settings with high statistical heterogeneity, such as in iNaturalist, there is a significant negative impact during the aggregation phase for the FET3R plus FT and FET3R plus FT LP experiments, as the classifier is fine-tuned and becomes susceptible to the classifier bias phenomenon. Conversely, Keeping the classifier fixed and only fine-tuning the feature extractor as in Fed3R plus ftfit experiments eliminates this phenomenon for the classifier, ensuring performance improvement and more robust training. If you have questions, we will be happy to answer them at the poster session 5 of ICML. Thank you for your attention.